I want to thank you all so very much for coming today. I'm probably going to get a little bit emotional because us and our partners have put in a ton of work, tons of sleepless nights trying to figure out what is the right thing and the best thing to do for our customers, and how do we make sense of this new technology called blockchain. Today I'm privileged to be in company of Aaron McGill, who is a fellow solutions architect leading our emerging partners on ISV and SI sides. So we help companies from startups, they're just trying to figure out how to get the bearing under them, down to the giant corporations and which have done tremendous work globally from SI and ISV perspectives. We will also today hear from our partners, Kaleido, who's built out an awesome solution. It's a SaaS platform leveraging Quorum and Ethereum protocols, which was a brainchild of Consensus in AWS partnership last year, or this year still. Feels like a long time. And also from Cisco, who's always been a leader in networking and looking to leverage a lot of their lessons learned in connections and networking and bringing this to the blockchain world. And this is the introductions that I just went through. And without further ado, I would like to pass the mic to Aaron.
Thank you, Lana. All right, so I just want you to be aware of another related breakout. It happens tomorrow, so make note. All right, so what I'm going to do is I'm just going to talk about some blockchain basic concepts and some of the use cases that we're seeing our partners and customers building solutions around blockchain on AWS. So usually when I talk to people about blockchain, I get one of two reactions. The main one is Janet Yellen going, okay, sure. And then the next one is these guys. The hype machine is out there. There's tons of hype around blockchain, but we're here to really kind of separate hype from reality and what you can actually really do with this amazing new technology. On AWS, we have customers and partners building business solutions to solve business challenges around blockchain, from agriculture to energy, financial services, and supply chain, among many others. And how do they do this? They do it by building a blockchain network. It's a technology that makes it possible to build applications where multiple parties can interact and record transactions without the need for a central authority. Blockchain enables this by creating a peer-to-peer network where each participant within that network has access to a shared ledger of the transactions that are recorded. So these two parties can interact without having a third party or central authority to verify that these transactions are valid and should be on the block. This is achieved by our consensus mechanisms that agree on the validity of the transactions within the network. Oh, there we go. And these transactions, by design, are immutable and independently verifiable. So when you want to build your next solution, why do you want to use blockchain? What would be your goal? What are the reasons why you'd pick it? Well, first, you need multiple parties to interact with each other and transact with each other without knowing each other or having an established trust relationship. You need an integrated data store that has built-in cryptographic security. And you also need a state machine where all the transactions are recorded and they're attributable to one or more entities. And each of those entities can go back to the records and verify them independently. One of our partners, Consensus, worked with Union Bank in the Philippines to build a blockchain platform for their rural banks to bring banking, to allow their rural residents to transact out there where they usually wouldn't have any banking resources. So this is a graphic representation of a blockchain itself. It's an immutable chain of files where the data pertaining to the network are actually embedded permanently in a record or in a block. And these blocks are linked together through a cryptographic hash. And as you can see, the previous hash from the block before it is embedded within the block itself. So if I were to go in and I wanted to change block 1 and the transaction within it, I would actually have to then calculate the next block 2, and then 3. And then I would have to have the whole network agree on that consensus that, yes, my changes are valid. And how do we reach this agreement that these transactions are valid and that my block gets appended to the chain? Consensus algorithms. Consensus is a critical element of blockchain. Generally, the technique by which information is reviewed and confirmed before being accepted to the next block is through these consensus algorithms. Consensus algorithms are designed to achieve reliability in a network involving multiple distributed nodes that may or may not be reliable, and that these nodes will independently verify and validate these transactions reliably without having some sort of central authority. So one of the consensus algorithms I wanted to talk about was proof of work. So this is a requirement of a service requester to actually do work. It's usually processing power in a computer before they're able to interact or engage in this system. Then we have proof of stake. So this uses a distributed set of validators whose sole purpose is to propose and vote on the next accepted block in the chain. These validators will lock up some sort of stake. So in cryptocurrency, it would be some coins. Meaning that when they discover a block that they think is a valid transaction and should be appended to the chain itself, they'll place a bet on it. There's a little bit of a challenge with this consensus algorithm because, say, you're a validator and you see all sorts of blocks that can be possibly valid and be appended. You could just bet on all of them with really, no matter what happens, you'd win in that situation. And then we have proof of authority. So this delivers comparatively fast transactions through a consensus based on identity. You have these approved accounts known as validators, and they run software that will automate putting the transactions on the block. And these parties, they earn that right through reputation to be able to become a validator. So this incentivizes them to kind of keep up their, to uphold those transaction process and keep their reputation that they have earned. This is a bit centralized, and is mostly used in what we would call a permissioned blockchain. Then we have proof of elapsed time, or POET. This was developed by Intel. It's similar to proof of work, but it consumes less energy. So proof of work is pretty energy resource intensive. And in this case, it's based on a guaranteed unit of time provided through a trusted execution environment. And then lastly, I want to talk about endorsement, ordering, and validation. This is really a consensus algorithm that's used by Fabric. The endorsement is driven by an established policy in the network upon which the participants endorse a transaction. And then you have the ordering phase, and that accepts the endorsed transactions and agrees to the order in which they will be committed to the ledger. And then we have validation, and it takes a block of these ordered transactions and validates the correctness, including checking the endorsement policy and ensuring that there's no double spend within this transaction. So I'm going to bring up a matrix of blockchains, comparing them, the consensus algorithms that they have available, as well as some tools or ways that you can run them on, that we have provided at AWS, where you can kind of get them up and running quickly. The first one is Aetherium. This introduced the concept of smart contracts. And really, this allowed blockchain to be more appealing to a broader audience of developers and enterprises, that they can use blockchain in different use cases. So that Union Bank in the Philippines example I used earlier, they use our partner Kaleido's SaaS solution to address the challenges of building a multi-organizational blockchain network. We also provide CloudFormation templates in which you can launch in your own account and play with Ethereum if you'd like. Then the next one we have is Fabric. Fabric, we also provide CloudFormation templates. It is a permission network. And in Fabric, this is the one that uses the endorsing, ordering and validation service. Does give you the ability to swap out each of those stages within the consensus model, and it provides Kafka as a default. And then we have Sawtooth Hyperledger. Sorry, excuse me. So with Sawtooth, you can launch a Sawtooth network using the AWS Marketplace. And by default, it does use the POET consensus algorithm, but it supports other algorithms as well. It's built with security in mind, so that with minimal resource consumption. So our customer, Farm Mobile, they created a Farm Mobile data store for farmers that can then interact with data buyers in a trusted and transparent manner. And then this would decide to, yep, nope. Ha. I just wanted to cover Corda a little bit. So Corda, oh right, I'm going over. Sorry, but Corda, so the team at Tradewind Markets, they created a blockchain-based platform called Vault Chain. This makes a simple and efficient way to invest directly in the physical gold market by moving the physical gold trading onto an electronic platform that they selected, Corda, due to its ability to isolate data, to offer privacy, and provide developer-friendly technology. And with that, now I'd like to hand it over to Lana to talk a little bit deeper about blockchain and some architectures. Thank you.
Okay, so now that we have a pretty solid overview of what blockchain protocols are, you can't cover everything in this 1 hour session, so we're trying to equip you with enough knowledge to where you can go out and start building right after. So you can have a pretty good understanding of how the transactional data is stored on the chain, the fact that once you put it, you can't move it, the fact that consensus is extremely important when you're trying to outweigh whether you need trust more or transactional throughput. This is why we're kind of laying out multiple options, and we're working with a lot of partners in the space from both ISV and SI perspectives to offer these solutions via quick starts, AWS Marketplace, SaaS solutions, and our own CloudFormation templates. So now that we have a pretty good understanding of what blockchain is, let's look at an example of digitized assets. It's a pretty broad topic, I guess, but myself, I started building anti-piracy systems for software licensing, so I understand intrinsically what it is trying to secure a digital good on a network that you don't trust, especially so in virtualized environments. So this is when we're trying to figure out how do we look at designing these blockchain systems outside of just a Bitcoin network that relies on proof of work. Proof of work is wonderful in certain use cases. It's been proven to work for the past 10 years. So, and then we've all celebrated Bitcoin anniversary 10 years ago. 10-year anniversary. But now let's look, how do we apply the same paradigm with maybe slightly different architectures to enterprise use cases. Whenever you're building your blockchain platform, you cannot separate the business use cases from technical and from legal. This is all one state machine and machine of truth that you have to understand the entire business process to build a proper architecture. So whenever you're having your conversations with your decision makers, please make sure that you're in the room. And the reason that's extremely important is that you cannot define governance or the smart contract layers without understanding what exactly does your business network look like. I was in the room in Kansas with our guys from Farm Mobile, and we're trying to figure out how do we make farmers trust the government or the large manufacturing providers of their equipment. And what do these people and organizations do with their data? So it was really important for me to be in the room with them to actually go and check out what does the field look like and why they're trying to give control back to the users of the systems. Control over their data, who and how they sell it to, and how they transact on these networks. So business is incredibly important because this is your smart contracting layer. Technical. So technical is your immutable data store that we've discussed. Immutability is something that's really important for blockchain. I know there's been a lot of conversations about making appendable chains or going back and doing all kinds of chameleon hashes and so on and so forth to delete information. It kind of defeats the purpose in a lot of ways. So when you're designing these systems, please keep in mind that whatever you write on blockchain stays there forever. It makes it an incredible tool to cut out extra audits. How many of you guys and ladies like audits? All right, you're probably an auditor, so there is a feature for you in this whole thing. So they're fantastic use cases just from the technical perspective, and also legal. So legal, not only from the much hyped ICO perspective that I think we all either know somebody or have heard of somebody that's been pretty terrified of, what does this mean for our ecosystem at large? But also legal in automating smart contracts as legal agreements. Something that our partners from R3 have established early on is that, yes, us as developer nerds, we think code is law, but we do live in the real world, and a lot of us have day jobs, so we have to go by law is law. So we're actually making these agreements binding in a lot of cases, which provides this level of trust that make blockchain truly usable for the enterprises. So this one is a little bit of a contested one. So I was trying to come up with a good example of show how are you trying to layer business, technical, and legal aspects onto blockchain. I'm probably not the only one who's had these peer-to-peer solutions on their laptop back in college or high school, and I think I'm dating myself there. But we learned how to distribute files quite efficiently. Now we're looking to see how can we actually distribute royalty back to the rightful owners. And what were we decentralizing against? Some people say that if it broke, don't fix it. I say if it's inefficient or expensive, please do fix it. So I had a really nice slide here with Nickelback because it's the greatest band of all time, but a lot of people disagreed. So this is something I took at a concert back whenever I had time. So this is an extremely great example of how digital asset management can be bettered by blockchain. So here we see a combination of a digital asset, which in this case can be either a ticket to event, music track itself, or merchandise or loyalty system. So either one of those are kind of your pieces of data that you're storing on the chain. Then we're also seeing that there are some symbols here of a house, and then a computer, and then your stuff. So this is the nodes on your blockchain network, where used to be separate systems. And as we know, that the more data you pass between the systems, the more silos you create, and the more inaccurate data set you get at the end. So this is something that blockchain helps us with. Also, we see actions. So asset created, offer created, and offer accepted. So these are going to be your smart contracts or smart contract methods depending on which blockchain solution you choose to go with. So at the end, in the case of e-tickets, which our partner BlockApps has developed, you can not only provide me as a concert goer with knowledge that my ticket is authentic, but also can cut out some of the middle layers of scalpers and just other resale sites that might be too expensive and cost prohibitive to both the venues and the concert goers alike. And a third, which is quite interesting, is that blockchain provides a very novel way for us to understand who our users are without having to have a burden of storing their PII information. So in this case, somebody can authenticate into this system without providing their names, addresses, or anything else. And for me, as a ticket provider, I don't need to know or store their data, but at the end of the day, I know who the user of the ticket is, based on certain attributes that might choose to show us within some kind of a system. So this is just a base understanding of digital asset management. So something that's interesting is that we've used this exact setup with FarMobile, who Aaron has mentioned. And what we did there is that we realized that the farmers actually are collecting data that's extremely valuable for them. And they can yield crops at 300 to 400% higher than their neighbors. And they do have some IP that they're entitled to. So we're enabling them to be able to sell this data and share it with whoever they choose to. This is what a distributed application stack usually looks like. As we've discussed, so some of the applications don't necessarily have to be decentralized. There's a lot of conversations between the differences between decentralized and distributed. Decentralized is more about the governance. So it's more about the governance of the network itself, who makes decisions on it. Distributed is something that doesn't have to live on the same server or data center. So applications that are users of your blockchain platform can absolutely be just distributed. That's completely applicable. APIs become increasingly important here. So blockchain networks are still evolving very rapidly. Some of them introduce breaking changes known as hard forks. This becomes very important when you're going to production or in enterprise use cases. And then we start understanding that if you're bringing on new members on the network, you have to figure out what does the membership look like, cryptographic services involved in signing transactions and on governing the membership of the network alike, and also how do you tackle some of the architectural things, such as event and transactional throughput. And then only underneath it all, we have consensus, smart contract, and distributed ledgers that we've covered. So what is the easiest way to get started? In this talk, we're not going to talk about how to write your first smart contract. We do have some blogs that are available on the marketplace, on a AWS partner portal, and a ton of just data you can find from Corda and Consensus and from other projects. Here we're going to talk about how do you use AWS infrastructure whenever you're trying to or you're working on bringing your project to pilot or production. So that's our focus. So me as a former developer, understanding that your CI/CD is proper and that you're maintaining clear separation between development and production environments is very important. It becomes incredibly important since once the smart contract is launched on Ethereum, let's say, there is no way to change it. So you don't want to have your, oh man or woman moment and realize that you've launched something in production that essentially becomes a cash pinata. So you have to understand, you have to test your projects from A to Z, and the fastest way to do it is just throw up a truffle on Cloud9, which is our cloud-based IDE, which allows you not only to understand the structure of a blockchain project, but also shows you things or something like smart contracts. So there shows you in the folders, so you kind of can inspect and understand how they work. Migrations and other configurations, such as specifying what kind of wallets you're using and what kind of deployment points that you're deploying your networks to. So you can actually deploy these contracts to anything. You can run them on the Ganache, your own network that's running within your instance. You can deploy it to a SaaS solution like Kaleido, to Ethereum framework templates, or anything of that nature. And then we're going to blockchain node architecture. And I'm trying to speed through this to give our partners time to show us exactly how they brought these systems to production. This is the typical blockchain node architecture. Blockchain is not highly available as much as you think. So whether it's a public blockchain, a lot of the clients are still pretty unstable. And if you're talking about truly public chains, they're very, very expensive as far as storage goes. So it takes hours, sometimes days to sync nodes. So you have to make them highly available. And the only way to do this is by actually building HA nodes. So these are becoming your logical nodes. In this case, we're showing how to use Elastic Load Balancer to split traffic between your nodes, and also how to protect your private blockchain nodes, let's say, from outside traffic. Ledger data should be split also between two AZs to make sure that you can fail over quite efficiently. And never forget about CloudWatch as a way to monitor your nodes to make sure that the block height and everything else is proper. So we've applied this paradigm to numerous blockchain protocols. I've mentioned the public ones, but the private nodes become more specialized. So the way we're making blockchains more applicable to enterprises is by applying paradigms such as unpluggable consensus. So for example, if you have a pretty high trust level in your in the network that you're interacting with, you can drop some of the algorithm complexities needed to achieve consensus on the chain. So you can use something that's just maybe crash fault tolerant if you have to. And it becomes really important to do it this way. Also, some blockchain protocols such as Corda or Fabric and a few other ones only store transactional data with the nodes that you choose to trade with. So for example, if I'm trading with you, I don't want this guy to know what we're doing. So I don't want him to even know that we have transactions that we're sending between each other. So this is something that specialized blockchains do quite well to kind of fit more business use cases. And this is what a blockchain platform will look like once you bring it to production. From this perspective, I want to point out just a few points here before I pass it over to Steven, not Steven, Peter, I knew I was going to do that, is that on blockchain, on your blockchain platform, once you're done with it, a user should be able to use it, a node, which represents either a company, a government, or any entity, and then any device should be able to communicate with to make it truly applicable to numerous use cases. One of my favorite sayings is that on the blockchain, you can be refrigerator. So nobody has to know. So this is how your IoT devices will fit in for use cases from pharma to supply chain to and so forth. Networking is extremely important. A lot of financial institutions have federated requirements of how they treat traffic. So we have services like Private Link, which allows you to join accounts to each other without exposing them to public internet. And CloudFront with API gateway for users themselves. The core blockchain platform consists of 4 major components, so membership and identity for onboarding and offboarding members, transactions and messaging, this is your scaling mechanisms, compute and security, and you can plug and play with quite a lot of those services, and also off-chain storage. These slides will be available after the presentations, and so will we, if you have any additional questions. But I wanted to just touch just a little bit on the off-chain storage. This becomes really important, first of all, to not bloat your ledger. So once you're starting to build your production workload, really take some time to understand what data you're storing on the chain. So I would stay away from storing any API data, especially with GDPR requirements that a lot of us have to deal with in our daily lives, or other privacy concerns. And also the size of the files that you're storing on the ledger. So larger files, it makes sense to store them on one of these storage solutions. So for example, to store something on a public chain, it could be up to, I think a gig is up to $500,000 versus just a few cents in S3. So financially, it just makes more sense. And also, we didn't forget about some of the advanced security features for public blockchain builders. So we do have security solutions that make it more easy and cost efficient to implement systems based on proof of authority and proof of stake or delegated stake. And more than happy to dig into these deeper. Essentially, it's a way to sign transactions and to make sure that you can validate transactions fit to your consensus algorithms defined by your networks. So this is a larger overview. I would like to introduce Peter from Kaleido and let him talk through a little bit how they've used AWS services on building Kaleido SaaS on AWS.
Hi, thank you, Lana. So I'm Stephen, like Peter, from Kaleido, and we launched the Kaleido platform back in May, and we've had an exciting 6 months working with some of the most interesting and credible enterprise blockchain projects that there are out there. And we're really excited to see projects like I2I mentioned earlier with Union Bank getting to the point of real production this year. And there are a number of others that I'll talk about later that are really breaching past the stage of pilots and into real production use cases. And the use cases are really varied, which is awesome. They cover some of the standard things you've heard in blockchain, like post-trade settlement in finance. They cover supply chain. They cover healthcare. And we're working with all of those types of consortia. But there's also a huge long tail of really interesting projects in the over 1,000 chains that we're running on Kaleido today. But there's a common journey that we're going through with all of our sponsored users. And it's a journey from concept to try and get to a real, actual consortium which is delivering business value. And it starts with POC. It starts with understanding this radically different technology stack. Open source, containerized, using new programming models like smart contracts, new languages like Solidity, understanding that core technology, and then moving on to where the really interesting problems come in. You're building this permission chain, private, between a number of organizations, but it's no longer just your IT organization. It's across multiple IT organizations with shared responsibility for the availability, with shared project schedules, with shared data flowing between separately managed infrastructure. And then the goal is to get to production, and this is where we are with our customers, seeing customers relying on Kaleido to avoid any of those single points of failure that Lana was talking about earlier, to have that automatic high availability failover out of the box across AZs, to be able to run in a decentralized manner with governance that allows them to run these enterprise consortia across organizations, meeting the regulatory compliance across all of those organizations, as well as the IT requirements of each of those organizations. We'll talk a bit more about that later. But first, I'd just like to give you a really whistle-stop tour of the Kaleido product. This is all stuff that you can go and do in production on Kaleido today. So we're going to log in, and we're going to go and create a consortium. A consortium is the group of business organizations that are getting together to do the project. We're going to name it, we're going to define our business purpose, and we're going to choose which of the production regions across the globe in Kaleido we want to home our infrastructure in. We're going to introduce ourselves. Maybe we're going to establish a PKI-backed identity for our organization that proves who we are to everybody in the chain. We're going to go and create an environment. We're going to choose our protocol. We're going to choose our consensus algorithm from one of the permissioned specialist consensus algorithms that we have in the product, representing fault tolerance. Maybe we're going to anchor our small chain to the public mainnet to give additional proof against collusion. We're going to go and create some nodes. We're going to choose their sizes, choose how much throughput we want to have, maybe choose whether they're able to sign blocks or just maintain a copy of the ledger. And there we have a blockchain. It's a technical blockchain, but it's not really fully decentralized yet because one organization is in control of all of the infrastructure. So what we want to do now is we want to invite a separate organization to go and run their own nodes, their own data, their own keys as part of the same consortium that we're in. We want to use a decentralized way to pass on permissions, passing on permissions that you have to new members, maybe only passing on some of those permissions, but in a decentralized manner so there's no single point of failure. We obviously need to be able to then manage those nodes. We need to be able to see how much resource they're using, monitor them, and of course this is SaaS, so everything that you're seeing here today can be done via the API. All of this data, all of the administration can be done with trivial examples that we have in Kaleido to go and create these chains, automate them as part of your pipelines. Then, of course, you need to connect your applications and your infrastructure into these blockchains. Click through to connect, and you can see you've got the strong credentials there to connect in, as well as that integration option that uses an integration technology that we've open sourced, ETH-Connect, to provide a simple REST interface to be able to submit transactions into the chain from any enterprise integration that you have today. So that's Kaleido in a nutshell. Let me get back to some of those use cases which are so important, and let me talk about one of those really interesting and novel use cases which is happening today. We have Green Fence Consumer, who are creating digital swag bags. digitally scarce artifacts that you can get by attending an event like Hollywood on Blockchain that we were at a few weeks back, or by going to a geofenced location and in conjunction with, for example, Sony on the launch of Goosebumps 2, be able to go and get this piece of digital artwork. But beyond just having this interesting, unique thing for a rich user experience, being able to actually prove that you are one of the select few that has this via a decentralized ledger on a blockchain. And Greenfence were able to get there extremely quickly using Kaleido because it was performant. It was there immediately for them. It was click, button, simple. And it ran and gave them the reliability that they needed to use this as part of the launch with these large media companies. And I've talked a lot about the chain, but what's so interesting working with all of these different projects is that we've heard a maximum of 20%, generally about 10% of the investment in these decentralized applications, because that's what they really are, is the chain itself. So what we've done in Kaleido is we've taken that experience and we've brought it back to this reference architecture here, where we're actually talking about what does a real decentralized application look like, because it's way beyond the chain. The chain's critically important. Of course, you've got the shared data there on the chain. Maybe it's just some proofs, something that happened off-chain. Maybe it's just some votes, etc., that's allowed you to have an irrefutable proof that something happened. Maybe it's more sophisticated business logic encoded in smart contracts, which is dealing with the full life cycle of assets. But beyond that, you almost certainly need other things on the chain, such as an identity registry. If this is going to be a permissioned network, everybody needs to know who everybody else is. And what better place to store that than on the chain itself? So we'd expect every enterprise permissioned solution to have that sort of identity registry on the chain. But to get the chain, you need infrastructure. And you need that infrastructure to be run in a cookie-cutter template across multiple organizations with decentralized ownership of the data and administration of that infrastructure, with the secure, private, isolated networking that allows the fast UDP traffic between these separately administered environments. And beyond that, you're probably, in this decentralized application, going to have a lot of off-chain data as well. You're going to have files, things much larger that can fit on the chain itself. You're going to have you're going to need to be able to share those files. You're going to be able to need to have private end-to-end secure communications, maybe private transactions. And above that, each organization is also going to need to be running an application tier with APIs, caching layers, with identity masking, with key management. Now, key management's a critical piece here. With integration to their own IAM to be able to authenticate their own users, to be able to perform actions through the user experience and mobile application that they've got. And you're going to need app integration into your core systems, otherwise this isn't going to be a core part of your business. And each organization in the consortium is going to need to be able to run completely customized versions of these. So what we see is that they're either built through collaborative open source between the participants, or a consortium entity is built that actually comes together to be funded to build that infrastructure and allow it to be customized. So this is the pattern that we've just seen time and time again. And beyond just writing a chart, that's pretty easy. What we've actually done in Kaleido is we've taken this and we've actually built the full stack blockchain experience through a back button. There's going to be a back button here.
It's the red one.
Red one? Magic, there we go. Into the products. If you go to marketplace.kaleido.io, you'll end up here. And you'll see that we've built in AWS integrations into your private AWS account for private networking, for secure backups, for portability of your data, key management, to be able to provide an additional layer of KMS security with a master key encryption on your keys. A growing set of partner services like OpenLaw that allows you to codify legal contracts on the chain. And those critical infrastructure components which sit above the chain but need to be decentralized, like an IPFS shared P2P file system. One-click deployment through Kaleido. In this case, I don't have a chain, so I'm going to click through a wizard to create myself a sandbox, have a sandbox up and running with an IPFS node there, add IPFS nodes, they're all going to join the same network. I can add other services like Chainlink, which is a decentralized Oracle platform, and we'll see what that means later, allowing you to get data into your smart contracts to run. And we don't leave you there to hang. We also give you a samples gallery to show you how to use all of these services. So IPFS, for example, here, this is code that shows you how to deploy, how to send a file via the APIs up to IPFS, get shredded, distributed across the nodes, and then you can go and download it from any of those IPFS nodes and have the nice picture that you uploaded. Or with Chainlink, to demonstrate how you could go and install a job spec into Chainlink, which says to the Chainlink node off-chain, go away and look up the price of Ethereum. On demand, look up the current price, pull it down to be used in the smart contract that we've just deployed there against the Kaleido chain, and then allow that contract to go and query that data, pull it on-chain where the smart contract logic is running that can't access the outside world, and use it in the execution of the smart contract. We've built all of this knowledge from working with really interesting consortia, and Comgo is one of the most interesting that we're working with. A group of 15 of the largest financial institutions and corporates in the commodity trading space in Europe got together, created a consortium entity, a new entity, to solve the problem of managing the finance behind supply chains. The letters of credits, the KYC needed to actually make these deals work end-to-end. Processes that take many, many weeks and months to complete, getting an order of magnitude faster through a decentralized application, reinventing the business processes, built on sort of blockchain and built using decentralized methods. And this is a really interesting story that you can go and read about if you go to the solutions section of the Kaleido.io website. And I'm also really proud to be standing here today after 6 months on the first day that Kaleido is out of beta. It's available, ready, production grade for prime time. You can go and sign up for free, use it in the starter plan, get started, try it, use it as your first blockchain experience or to get started on your journey with blockchain. And you can go through the plans all the way to plans which are suitable for enterprise grade production environments. And also, we're really proud with our plans that these are designed to support the ecosystems that you're trying to build in these consortia. So you can support having very large networks with different levels of participation in the same business network. So, thank you very much. I know that was a lot of information in a very short period of time. I wanted to leave you with a kind of call to action. Well, 2 of them, probably the one that you'll be most interested in. So the first is, come and see us at the Consensus booth and get a password to come to a party tomorrow night. So that's the most important call to action. And the other is go to Kaleido.io and go and give it a try. See that actually that blockchain journey from concept to consortium doesn't need to be as hard as you think it is. You can get going and get all the way to production grade very quickly. And with that, I'd like to hand over to Sridhar from Cisco to talk about the Cisco blockchain platform.
Thank you, Peter. That's good. So I'm here to talk about the Cisco blockchain. I know you heard fantastic things about the blockchain technology, and truly it is. Now, imagine a network where, I know you're all familiar with networks that companies like Cisco bring on board, right? Today they help to bring your enterprise networks, and they are used to connect your enterprises between them and beyond to the internet. Now imagine a network for business transaction. That's exactly what I'm here to talk about. My name is Sridhar Ramaswamy. I'm a principal engineer in Cisco blockchain team. Here, as you can imagine, the initial foray into enterprise use cases for blockchain is discrete use cases, right? And that's a perfect place to start, right? As you heard earlier, there are use cases around supply chain or trading, and that's exactly where the current need and current evolution of enterprise blockchain is currently happening. But Cisco's vision is to take this forward further into a multi-provider internet-scale trust network through interoperable open standards. Just like how today you don't have different networks in your enterprise, right? You have one network that takes care of your data, voice, and video. That's exactly how we envision enterprise blockchain networks will evolve. It won't be just for your single use cases. In fact, it might be for multiple use cases. And we are not doing this alone, right? We are partnering with the industry where we want to do this in a way where we can evolve as an ecosystem, not just Cisco, but as multiple providers. So Cisco is actually a founding member in Hyperledger, Ethereum, Enterprise Ethereum Alliance, Trusted IoT, and many others to make this happen. So I'm really excited to introduce the Cisco blockchain platform. It's an enterprise-grade blockchain platform that can take I-trust transactions into reality. And this is something we are bringing with our deep expertise in networking, security, and performance monitoring, which all three are really important in a context like enterprise blockchain. Like Lana mentioned earlier, your network layer is really critical to get this going. And towards that, how we are going to achieve this? Our take and the way in which this will get deployed is hybrid deployment. As enterprises start expanding to embrace blockchain technology, this needs to actually coexist with your existing data center practice. And many times you might have an existing data center that you want to bring your blockchain use cases into your existing data centers. Or you might have a public cloud presence. And this is where we had a fantastic partnership with the AWS, where we really worked hard the last many months, and we have something excited to share today. So Cisco now has an AWS Quick Start product where with the click of a button with some inputs, you can get this instantiated in AWS. For the folks who are familiar with the typical AWS architecture, you would find this really familiar. As you can imagine, it's an highly available architecture where different nodes are instantiated in multiple AZs. And for extra security, all the blockchain nodes are on the private subnet, and it's accessible only through a load balancer, in this case, a network load balancer. And here we found AWS is a fantastic platform to bring this on board with various services like S3 and managed Elasticsearch for transaction metadata. And this is something you as a developer, you would find it really useful where you can get this going today. And this is something actually hot off the press, just showed up last week. Beyond the basic blockchain network, Cisco is also offering various add-ons, and one of them is a developer portal. I know the developers in this audience will love to hear more about this, and I have a demo as well, where alongside the basic blockchain network you saw in the previous slide, you can also drop in the developer portal, which will be really useful, as you can see in the next demo. Okay, one more. There you go. So I'm going to walk through briefly on how this developer portal works. So as you can see, this shows different application bundles. And as this is the basic UI, you can see the number of nodes. That's your network. Again, all these nodes are in AWS, started by Quick Start. You can see the various transactions. Again, this is coming from Elasticsearch, which is a transaction metadata. And let's go ahead and create an application. Right. So like I said, this is a container of various smart contracts where you essentially give a name. I'm just going to give a simple track and trace application. So you go into the application and start adding smart contracts. Again, imagine an application that can have a collection of smart contracts for a particular use case. If you click Add Smart Contract, this tool readily comes with a ready-to-use smart contract. And again, this is in a familiar language like JavaScript. Here you can make use of this, you can expand and develop your smart contract, you can test it on the side, but here I'm going to go a little further and go ahead and deploy the smart contract. So like you see, right in this tool, you can test your functions, your methods, and now you can go out and actually deploy the smart contract. So there, it's currently not deployed, but now the smart contract is deployed in the blockchain. And again, the smart contract is in all the 3 nodes, and it's ready to take transaction. So now let's try those functions by actually executing it live. Here, as you can see, the tool figured out all the functions. So let's go ahead and create an asset. Again, you give a name and the owner of an asset. And as you can see, the tool, you can actually see the method right there in the tool. So you give let's create Kindle, and let's have Joe as the owner, and submit transaction essentially submits this to the blockchain network, and you can imagine all the endorsements, your verification, and consensus happens, and there is a transaction ID. Right. So next you can say transfer this asset. Again, you can imagine a life cycle of the assets transferring to different owners. So let's transfer the asset to, say, from Joe to Alice. This is another transaction to the blockchain network, and there it is. And now in the next step, you will quickly do who is the current owner of this asset. All this can be done right from the tool. This is something we think it will really enable this ecosystem of developers to use a tool like this to develop smart contracts. And as you can see the logs, for example, how the smart contract executed. And this is very useful, for example, in your initial foray into developing smart contracts. If there are any errors, you can catch it here. And if you go back and look at the activity, you can see new transactions there. Again, this is a quick preview of how you can quickly see. Again, you can see some of the transaction metadata, now the different stages of the transaction that happened here. That's a quick demo. Now that you have seen the technology, you heard the technology, where Cisco's vision is, and some of the tools that it's bringing on board, and either quickly deploying and having developers embrace this. But technology is great, but it doesn't mean anything unless it's solving real business problems. And that's where we believe we have some interesting stories to share with the community here. One of the key issues our Cisco supply chain team faced is around counterfeit. Cisco supply chain, as some of you might know, is a huge organization. In fact, Gartner rates it, it's one of the top supply chain organizations in the world. It handles hundreds of assets across multiple partners. And as you can see, the complexity of that ecosystem. So here we have specific issues in different products around fraud and counterfeit, particularly in some of the high value assets like the one you see is the optical module. They are high value, and there are sometimes there are a lot of counterfeit that shows up. And we need these components to be authentic for us to deliver the quality that our customers expect from a Cisco product. So we used blockchain to basically onboard all the assets. In fact, close to 200 million assets has been ingested into a blockchain that's live today across 7 to 8 nodes that's distributed across the world. Some nodes are private nodes running in some data centers of our partners, and some are in AWS. And they run the blockchain protocol, and they quickly provide a tool for our investigators to see whether whether an optical module is valid or is it a counterfeit. And you can also see the genealogy of how these components got changed, right from the supplier, manufacturer, distributor, all the way to the end customer, and where we can see the provenance of the optical module. This is a huge OpEx saving for us from the Cisco blockchain, and that's in operation today. Beyond the supply chain, we also have a fantastic use case around smart cities. This is, by the way, a landmine for blockchain for the folks who are interested. The reason being, smart cities is never a single enterprise. Smart cities always involves multiple solution providers coming on board to provide a solution. And there are multiple use cases. I'm just going to illustrate one. Energy trading. And this is where some of the advanced countries who are like really in the forefront of clean energy, they are enforcing energy credits for the folks who generate clean energy and make these credits tradable. And that's exactly what we are working with some of our customers in Southeast Asia. And this is actually a fantastic use case for a blockchain, where there are different parties in a consortium to make this happen. A single enterprise solution wouldn't cut it to solve this problem. Again, here the solution is to pick the right use cases for blockchain, right? That where there are different parties involved, where this technology shines. And beyond smart cities, in fact, we were like fascinated to bring the blockchain technology into our core networking products. This is where we found there is a need to audit the configuration of our platform, where typically you would have an external auditor do some compliance checks for your network configuration. Again, this is where it could be for various legal reasons. You want an external auditor to validate your network configuration is something that they could vouch for, right? And there are some insurance products that can be made out of this. And this is one thing that Cisco is actively pursuing today, to apply blockchain into its core networking business. So, in summary, I want to leave you with 3 key messages. Cisco is building a blockchain platform from scratch with an advanced privacy and various confidentiality features today, and that can bring real new revenue or save your OpEx. And also, it's not just these products are available today, they are easy to deploy in a cloud like AWS, that you can go ahead and try it right now with the AWS Quick Start product and our AWS Marketplace product that's currently available. Allowed to take any questions offline, and here are some resources to reach out to us after the session. Thank you so much.
Thank you all so very much for coming to this session. We hope you've learned a lot of how we work with AWS partners on bringing new solutions online. I'm hoping to see more of you on stage with us next year and leveraging AWS services on bringing full-scale end-to-end solutions globally with our partners in our core services. And please don't forget to fill out a survey. Let us know if you would like to hear more from our partners, and any other feedback is greatly appreciated. And we'll be around if you have any other questions. Thank you.